we did this. I skipped this part, right? And we did the tables down here at the bottom. Okay, so we need to go back to solving nonlinear inequalities. So, nonlinear inequalities, nonlinear means that we have a higher degree than 1, right? So we've got like x squared, we've got x to the third, we've got something of that nature. Whenever we solve nonlinear inequalities, let me give you an idea of what, well, up here we're talking about looking at where the graph is greater than or less than 0, right? We talked about that here. So what we're going to see down here are going to be problems where we're solving for where some expression is greater than or less than, or not usually equal to, greater than, less than, greater than or equal to, less than or equal to 0. If we could graph it, if everything was calculator active, we could just type it in and look for where that graph is above the x-axis or below the x-axis. However, we are going to see some of these show up on calculator inactive sections. So we also want to think about how we can reason through it given what we have here with a sign chart. That way we'll be able to do it both with the calculator. That'll be hopefully very simple to us, and without the calculator as well. So, whenever you are thinking about nonlinear inequalities, the first thing you want to do is find everywhere that that inequality equals 0. Those are the zeros of the polynomial, right, which we worked on at the beginning of this here. So you want to find the zeros, because whenever we're talking about a function being greater than or less than 0, we're talking about it going from negative to positive or positive to negative. And the only way you can get from negative to positive is to cross 0, right, if you have a continuous function. So, so we need to know where this function equals 0, because that's going to be our cutoff points. That's going to be the places where we switch from positive to negative or negative to positive. So we're going to look for our zeros of our function, and then we will create a sign chart, which I'll show you what that looks like here in a second. And then we will test values in each interval so that we can tell if they are positive or negative. So right there in those two little blanks, we've got positive or negative. And then we will interpret the sign chart to answer the given inequality problem. We will be sure to write our answer in interval notation and think about the endpoints for this. This exercise is also very helpful for something that we do in calculus. In calculus, we will make sign charts to determine if a function is increasing or decreasing to find maximum or minimum points. It's a little bit different than this, but it's similar in the way that we make the chart, or the way that we think about whether a function is positive or negative. So what we're doing here is going to be helpful in the future as well if you find yourself in a calculus class also. So the first thing that we would do is we would find all the zeros. All right. So this is going to be a pretty easy zeros because it's already factored for us. So we don't have to factor anything. We just know that we have x equals 3 is a 0, x equals negative 1 is a 0, and x equals negative 4 is a 0. Okay, so what we want to do, when I make my sign charts, I make them look like this. When you look at the ones like on the answer keys for this, Mr. Passwater's might look like a little bit different, well, a lot, because he's typing them in, but it's the same idea. So you want to put your zeros on a number line, make sure they are in order. So you need lowest over here, so you'll have negative 4, negative 1, and 3. So there are two ways that you can do this. You can just test points, or you can make like a chart where you test each individual factor. I prefer testing the factors because it's overall going to be a little bit quicker. But I'm going to show you both right here so you kind of understand what's going on. So what I really need to know is in between -4 and actually below -4, that's my first section, right? I need to know whether or not I'm going to get a positive or a negative number whenever I plug in anything that's in that section, right? It doesn't matter what number I pick between, here is negative infinity, here is positive infinity. So from negative infinity to -4, doesn't matter which number I pick because all of the numbers there, if I've done my zeros correctly, should have the same sign. So I could pick -5 or -7 or -10 or -1,000. Most of the time, kids are going to pick -5. Stick with smaller numbers, right? So if you think of taking -5, that would fall right here, right? If you plug it in, then you've got -5 minus 3 times -5 plus 1 times -5 plus 4. And that's -8 times -4 times -1. Now, you really don't care that much about what the number is. You care about the sign. So, I mean, this one's not too hard to do. -8 times -4 times -1 is going to be -32, right? But all we really care about is the sign. So we're going to put a negative right here. So if I plug in a number between negative infinity and -4, I'm going to get a negative number. If I change that -5 to a -9 or a -10 or a -1,000, I would still get a negative number, right? So I'm going to switch to the next section between -4 and -1. You have infinite numbers to choose from there. You could choose -3, you could choose -2, you could choose -3.5, you could choose -1.2. I would use -3 or -2. Use whatever's easiest. I'm going to go -2 right here. And then you're plugging it in. So you're doing -2 minus 3 times -2 plus 1 times -2 plus 4. And that's going to give you -5 times -1 times +2. And so here, I've got negative times positive. This is going to give me a positive 10. So in this section, you're going to get a positive. We got 2 more sections to test, same way. So I'm going to go over here. Between -1 and 3, you got lots of numbers to choose from. 0, 1, 2. Those are your easiest ones to pick. I'm going to pick 0 because 0 is always pretty easy to plug in. So if I plug in 0, I've got 0 minus 3, 0 plus 1, and 0 plus 4 right here. So -3 times 1 times 4. So negative times positive is going to give me a negative number. I'm getting -12 right there. So a negative here. And then our last one is going to be from 3 to infinity. And you can pick 4, you can pick 5, you can pick 10, you can pick 1,000, you can pick 1,000,000 if you want. But I'm just going to go with 4 right here. And if I plug in 4, I've got 4 minus 3, 4 plus 1, and 4 plus 4. So this gives me a positive 1 times a positive 5 times a positive 8. And so that gives me positive times positive gives me a positive number right there. Get positive 40 for that one. Okay, so this tells me the sign of the function on all of these different intervals, right? So the graph of this function would be negative here, be negative, positive between -4 and -1, negative between -1 and 3, and positive above 3, right? Those are our intervals. So I need to go back up here. I need to look right here. This tells me which ones are the answers, right? I'm looking for where this function is greater than 0. So greater than 0 is positive, so I'm looking for the positives as my answers. So these 2 sections right here are my answers. And so I would have, my answer here is going to be -4 to -1 union 3 to infinity. Now notice here that I used parentheses. I'm using parentheses because I have a greater than sign right here, right? Not a greater than or equal to, so I need to use parentheses. Plus infinity always has to have parentheses with it. If I have a greater than or equal to, like we'll see over here on 5, we have a less than or equal to, then I'm going to need to use brackets with all of my numbers. Infinity still has to have a parentheses every time. Okay, we good here? All right, now let me show you what it looks like with the chart. So we're going to look at like the same problem, but with the chart. So another option, instead of straight plugging these numbers in each time, is to think about each factor individually. Okay, so another option is that you can go over here and you can list all of your factors. X minus 3, X plus 1, X plus 4, and then I'm going to make this bottom line my answer line. And then I'm going to draw in some lines right here. And so what we can do, if we want to use the chart where we consider each individual factor, is I can think about X minus 3. And I'm going to think about the numbers that I plug into X minus 3. Well, if I plug in a number that is lower than 3, right? 3 is the 0 that goes with this. If I plug in a number lower than 3, I'm going to get a negative number, right? If I plug in 2, I'll get a negative number. If I plug in 0, I'll get a negative number. If I plug in negative 1, I'll get a negative number, right? Anything below 3 right here is going to give me a negative number. So I'm going to put negatives right here, and then I'm going to put a positive right here. Okay, if I go down to the next line, and I think about X plus 1, well, negative 1 is the 0 that goes with that. If I plug in any number lower than negative 1, like negative 2, or negative 3, or negative 5, or negative 10, right? I'll get a negative number, right? So this section and this section will both have negatives. But then after I cross negative 1, if I plug in 0, or 1, or 2, or 3, or 4, I start to get positive numbers right here. This can just, once you've done this a few times, it can be a little quicker than plugging into the whole thing, because you can just sort of see like which categories these fall in. So for X plus 4, the 0 that goes with that is negative 4. If I plug in a number below negative 4, like negative 5, I will get a negative number. But as soon as I hit negative 4 and go above negative 4, so if I plug in negative 3, or 0, or 5, or 10, I'm going to get a positive number. So this switches where I get positive numbers on these sections. And so normally that answer line would not be filled in for you yet, because we wouldn't have already done the problem the other way. So normally, in fact, let me just erase it here. We'll erase this line right here. Okay, so if we're doing a chart method, we haven't already plugged numbers in, right? And so then what I can do is I can just look down the list. And what I've got here is a negative times a negative times a negative, right? In this list. If I do negative times negative times negative, I will get a negative right here on that answer line, which is also what I got when I did it the other way, right? Negative 8 times negative 4 times negative 1 gave me a negative number right there. But if I have an even number of negatives, negative times positive, I've got 2 negatives, and when you do negative times negative, you get a positive. Then I'll get a positive in that section. Here, I would have negative times positive times positive. That would give me a negative. And obviously, if you have all positives, you get a positive there. So the chart just allows you to look at it. You're doing the same thing. You're looking at what's happening if I plug numbers into this chart or into this function, but it just organizes it and makes you a little bit quicker. It is up to you on what you want to do. It's still the positives that are the answer. You get the same answer either way. So if it makes more sense to you to just don't worry about this chart, I mean, you got to do the number line either way, but if you don't want to make the big chart, then just plug values into the full equation. But if you would like to use the chart, it is sometimes quicker. Questions on 4? All right, let's do 5. Let's just do the chart for 5. So for 5, we're going to have zeros at x equals -2 and x equals 5 there. So on the number line, we are going to have -2 and 5. Remember that your negative infinities down here, your positive infinities up here. And then for the chart, we're going to put all of our factors over here on the left side. So we've got x plus 2. You want to put the square with it, or you want to list it twice. It's easier to put the square with it, in my opinion. And then we've got x minus 5. And then we're going to have a line for the answer here. And we'll put these sections here. Now, I could think about x plus 2, but I really don't have to, because whatever I plug into x plus 2 gets squared. What happens when you square a negative number? Becomes positive, right? So you're going to get a positive on this line no matter what you plug in. So it's all positives on that line. So it really all comes down to the x minus 5. So the x minus 5, the 0 that goes with that is 5. So if I plug a number that's less than 5 in, so I plug in -4, if I plug in 0, if I plug in 1, anything below 5 right here is going to give me a negative value. All right. But then once I get to numbers bigger than 5, if I plug in 6 or 7 or 8, I will get positive here. And so I now just look down my line. If I've got a positive times a negative, that will give me a negative. A positive times a negative here will also give me a negative. And then positive times positive will be positive here. Now, to decide what the answers are, we're going to look right here. And we see less than or equal to 0 this time. Right? So less than or equal to 0 means we're looking for negatives. And it's also important that they put the or equal to sign there. Particularly in this case, because we've got two sections that are like right up next to each other. Right? That didn't happen over here where it wasn't an issue. But we've got two sections next to each other. If you have just a less than sign, you have to list those separately because you're not including the places where the function equals 0 there. So right here at -2, that is a 0. You would not want to include that. So if it was a less than sign, you would have to list these two sections separately. But it's not a less than sign. It's less than or equal to, which means we can include the zeros, right? So if you have an or equal to sign and you have two sections next to each other, you can combine those. But if you have like a greater than sign or a less than sign, like we had over here, you have to list each section separately. So for this case, the function is negative here and here from -infinity all the way up to 5. So your answer for this is going to be -infinity all the way up to 5. You're going to use a bracket with the 5 because it's an or equal to problem on this one. So the function can equal 0. Okay, so this function is below the x-axis. It is less than or equal to 0. It is negative all the way from -infinity up to 5 for this. Okay, questions? All right, that takes care of that. Okay, here's some even and odd functions. We talked about these the other day, right? We talked about them in that ACT prep stuff. So, for an even function, the big key you need to remember is that an even function is symmetric over the y-axis. You should be able to fold that function in half on the y-axis. And what it means is that if you have f of -x, that's going to have the same y value as f of positive x. So like, for example, like to do some examples here. F of negative 1, oh gracious, I've written where it does this crazy thing, should equal F of positive 1. Right? So if I think of writing on this graph right here, F of negative 1's right here, F of positive 1's right here. And those are at the same spot, even though they move down, because something about when those graphs are in tables, it like goes crazy. So this is an even function. Okay? Odd functions are a little tougher to see, just given what you're looking at. An odd function is symmetric about the origin. And symmetric about the origin, to me, when I used to teach geometry, it was always so confusing to teach to children. It has to do like being the same distance away from the origin, like on a straight line. But I just don't really talk about being symmetric or about the origin much anymore. Symmetric about the origin is equivalent to having 180 degree rotational symmetry. That's especially whenever you've got a piece of paper, it's a little easier to see. If you take that graph and you put your pencil right there on the origin and you rotate that graph 180 degrees, the graph will look the same, right? So like, let's see if it'll let me. Yeah, I can do it here. So like here, I rotate, oh, good gracious. Ooh, there's 90. There's 180. My graph still looks like the graph that you have on your paper, right? My X and Y axis are now like, there's still X and Y axis, but the negatives and positives have been switched the way that I flipped it. But the graph looks just like what you see here. If you rotate that graph 180 degrees, you get the same as what you started with. Now let me undo that. Oh. There. Oh, good gracious, what did I just do? Okay. We can also tell if a function is even or odd just from the equation, okay? Or for polynomials anyway, not for all functions, because you could have even functions like the one that we looked at on that, the ACT prep was a sine function, or a cosine function. So it can be other types of functions, but for polynomials, all exponents are even in a polynomial function if the function is an even function. Okay, so for this example right here, I see x to the fourth, I see x to the second. That looks beautiful. I got a 1 over here. 1, first of all, 1 is odd, and it doesn't have a variable with it at all, right? But if I put an x with it, which is going to go crazy because it doesn't like it when I try to write things in a table for some reason on this program. So if I put an x with it, I need it to be x to the 0. 0 is even, right? So any constant number has an x to the 0 with it, which is even, so this can still be an even function, okay? Now, the coefficients don't matter at all. So, like, for example, if I had 3x to the 6th plus 7x to the 2nd plus 9, all my coefficients are odd, but they don't matter. You're only looking at exponents for this. So this would be an even function. For the odd functions, all exponents are odd. Okay, now on this one, I've got x to the third minus 9x. This x does not have an exponent with it, but what exponent would it have if we wrote one in? 1. It would have a 1. So 3 and 1 are both odd. This is an odd function. Okay? If you have a mixture, if you have both even and odd exponents, then your polynomial is neither even nor odd, right? So there are lots of functions out there that are not even and they are not odd. They don't meet either one of these requirements. But because even functions and odd functions have these unique characteristics, where an even function is symmetric about the y-axis, and an odd function has 180-degree rotational symmetry, it's kind of nice to be able to recognize that because it tells you things about the graph that will help you understand what it looks like. Okay, so telling if a function is even or odd from an equation should be pretty simple. First of all, every term must have an x. So if it does not have an x, you're going to add 1. And since that had no x at all, it needs an x to the 0. Then you just look at your exponents. 4, 2, 0. And all of those are even. This is an even function. Okay. If I want to do b, every term needs to have an x, and it needs to have an exponent with it, right? So this x right here would be to the first power. And then over here, this term does not have an x, so really it's got like an x to the 0. Then, the only thing I care about are my exponents. 3, 1, 0. Right? 3 and 1 are both odd, but what about 0? That one's even. So this one is neither. Right? You will have neither even nor odd for that one. Okay, for odd, we get, if we didn't have that -1 on the end, then we would have an odd function there. From a graph, you are looking to see, is this function symmetric about the y-axis, or does it have 180-degree rotational symmetry? Right, so are either one of these even functions? They are not. Okay? So then we have to think about whether it has 180-degree rotational symmetry. That's a little tougher to see. If you have it on paper, you can actually turn it upside down, right? Like spin it 180 degrees. So that is helpful. Now, when you take my test, your multiple choice section is going to be on the computer, and when you take the actual exam, everything's going to be on the computer, but on the free response part, you'll write your answers on like an answer sheet that you turn in. So spinning it is kind of out of the question for those problems. Well, I think you guys, I don't know if you take them on Chromebooks. I think they usually put you on desktops for that too. So Chromebook, I guess you might could turn upside down, but please don't turn the desktop. Don't flip your monitor upside down in the middle of the AP exam. That might get us in trouble. Another way that you can tell here, note I kind of breezed over this. G of negative x equals negative g of x for this. So what that looks like here is that if I have the point, for example, now Mr. Passwater was not very kind to us here, and most of our points are not on grid lines. I think this one does kind of go through the point 1, -3 here. So if you have 180-degree rotational symmetry, I think you do this in Math 2 maybe. It's been probably a while since you guys had 2, and I haven't taught 2 in a long time, so I don't even know how in-depth they go with this. 180-degree rotational symmetry, if you have the point x, y on a graph, then the point -x, -y is also on the graph. So that means here, we change the sign of both points, so that means the point -1, +3 would be on the graph, and that happens here, right? We could check another point.
For example, they really didn't hit us with grid lines much here, and I mean, you could do this point. This point is 2, 0. So if you change the sign of both of those, you'd get negative 2, 0. But that one's a risky one to think about because 0 doesn't have a sign. So it could be a different type of rotation there. I'm just going to pick like 3. I'm sorry, that's 2 point. I'm going to go with 2.3. 3 right there. Right? That means the point negative 2.3, negative 3, negative 2.3, negative 3 should also be on the graph. And that seems to be holding true for all of our points, right? If I've got the point 1, negative 3, then negative 1, positive 3 is also there. So if you just change the sign of both coordinates, that point should also be on the graph if you have 180-degree rotational symmetry. This one does. This is an odd function. Now, if I check that over here, I can tell y-axis symmetry is much easier to see, right? This does not have y-axis symmetry. If I fold this in half on the y-axis right here, the two sides do not match up. If I check for 180-degree rotational symmetry, like you can probably tell if you flip, like if you rotate that, it's going to be upside down. It's not going to look the same. But you could also check with points. Like if I've got the point 3, 1 that is on this graph, if this function is odd, then the point negative 3, negative 1 should be on the graph. And it is definitely not. So this is not odd either. So this one would be neither. Okay, questions there? Okay, that's it for these, right? Okay, so what I want